All right, so this lesson is 5.5, solving equations by graphing. Essential question, how can you use a system to solve an equation with variables on both sides? So essentially what we'll be working with are two equations that we set equal to each other. And throughout your mathematical careers, on the ACT, on the SAT, when you get into upper division mathematics, oftentimes you will have equations that are set equal to each other and you'll have to find the solution to that equation. And one of the tools, one of the ways in which to do that, other than the future methods that you will learn in those classes, is by graphing and finding the intersection point. Okay? So that's what we're going to be doing today. We're going to be graphing a lot. We're going to be finding that intersection point. And again, if you have a graphing calculator, you have access to it, maybe a sibling has it, that can be incredibly helpful. So I will stop and show you ways in which you can use your graphing calculator to help you out. All right? So as you can see there with that core concept, it says just simply set the equations equal to each other for step 1, then graph the system separately, right? The x value of the solution of the system of linear equations is the solution of the equation ax plus b equals cx plus d. Do you have any questions about that? All right. So go ahead and write that down, and then we will solve it. All right, so as you can see, we have two equations that are set equal to each other. The first step that we want to do when we solve by graphing is to make a system out of that. So that's exactly what I'm going to do. I'm going to make a system. I'm going to say y equals negative x plus 1 and y equals 2x minus 5. I'm going to graph those two lines like I would normally. You have two lines, two equations of lines that are in slope-intercept form. So quickly, what is the slope for this red one here? What is the slope for that red equation? Negative 1. What is the y-intercept? 1. So again, you want to start at that point 0, 1, and then move down 1 to the right one, or up 1 to the left one. What is the y-intercept for this blue equation? Or what is the slope? 2. Positive 2. What is the y-intercept? Negative 5. So again, start at the point 0, negative 5, go up 2 to the right one, or down 2 to the left one. Now, your other question may be, that's all great, Miss Lynn. Why can't I just solve it? Why do I have to graph it? Because you could very well take these two equations and solve for x very easily. So negative x plus 1 equals 2x minus 5. And you could solve for x. You could add x, and you would get 1 equals 3x minus 5. Add 5, and get 6 equals 3x. And so you would get x equals 2, right? Well, that's not illegal. You could definitely do that. The point of this is, again, when you get into upper division mathematics, when you start taking the SAT, ACT, and PSAT, there are going to be some things that you won't remember how to solve, even when they're set equal to each other. This is pretty simple because it's a linear equation, but we might not have linear equations. We might have absolute value equations that are set equal to each other. We might have quadratic equations that are set equal to each other, and so oftentimes it's easier to graph it and find the intersection. So I'm going to go ahead and unveil this. And we see that we get an intersection at 2, negative 1, and our x value is the solution, which we got over here in the brown. We got x equals 2 as well. Does that make sense? If you have a graphing calculator, I'll show you, it becomes even simpler. Now, in Algebra 1, I will make you show the work so that you can, by hand, graph things. I understand that in today's technology age, that access to graphing calculators is something that we all have to be accustomed to. If the tool's out there, I do want you to use it, but I also want you to have the ability to demonstrate this by hand. So, if you have a graphing calculator, it's going to show up here in a second. It looks like this. What you want to do is you want to press y equals, which I have right here, and you want to individually enter those two equations. So you want to enter y equals negative x plus 1 and y equals 2x minus 5. So that's what I'm going to be doing right here. So I'm going to go down and get a negative, and then alpha x plus 1 and then go and type in the second equation as well, 2x minus 5. So 2x alpha x minus 5. And then you just want to hit graph. When you graph it, the graphing calculator will graph those two lines for you, and you see an intersection point. So what you would do with your graphing calculator is hit second, calculate. Go down to where it says intersect. You can either hit the number 5 or press enter. I'm going to hit the number 5. It has you pick a point on the first curve, so the first line. You just press enter. And on the second curve, it already moves, this point moves to the second line, so that's fine. I'm going to press enter. It says guess. You click enter again, and it tells you the intersection is 2, negative 1. Okay? So it does all the graphing for you. Really nice. And again, if you're on an ACT, SAT, PSAT, and you have a graphing calculator and you don't want to do the math by hand because you're on a timed schedule, pull out your graphing calculator. Enter the equations into the y equals, graph them, find the intersection in the way that you just saw, and then you can move on to the next question very simply without having to worry about doing the math by hand. All right. Go ahead and try this one. You may solve it very quickly by hand, but I do want you to graph it, verify that solution, and then we'll go over it. All right, so now we're going to transition to solving absolute value equations by graphing. And this is difficult in a traditional sense, okay? Now, I'm going to show you the way that we can do it graphically, and I'll show you the very easy way we can work on it on a graphing calculator, or work with it on a graphing calculator. One thing that you have to remember with absolute value equations is the definition of absolute value and the fact that it is the distance from 0. Because we're dealing with the distance from 0 with the definition of absolute value, we will be dealing with both a negative and a positive. Because we know if we plug in a negative value into an absolute value, it will give us a positive, and we will get an equivalent answer if we plug in the positive of that value. So this says that recall that an absolute value equation of the form ax plus b equals cx plus d has two related equations. So we're always looking at two equations when we're dealing with absolute value. So we're dealing with the original, ax plus b equals cx plus d, as well as the negative, ax plus b equals negative cx plus d. So we're dealing with several lines that we're looking at. Absolute value equations will have two answers most of the time, unless it's extraneous. That's why you always want to check. Go back and check your work. So let's first of all set this up correctly before we try and attempt to graph it. So according to my definition, I'm going to set up what I'm given to solve in this way. I'm going to take x plus 1, set that equal to 2x minus 4. And then I'm going to do the same thing, except x plus 1 is going to say positive, but what am I going to put in front of 2x minus 4? What does it say here to put in front of 2x minus 4? A negative 1, which will be distributed, right? So what I have is this. So in total, I'm going to have to graph 3 different graphs. We're graphing this one. I don't have to graph it twice here because I have it repeated. Then I have to graph this line in brown, 2x minus 4, and this line here, y equals 2x minus 4, but with the negative distributed. So, in other words, I'm going to graph y equals x plus 1, y equals 2x minus 4, and y equals what? What is the equation when I distribute the negative? Yes, negative 2x plus 4. And I should have 2 intersection points. I'll write that down. You should have 2 intersection points. So here you have both of those systems, or the two, system 1 and system 2, graphed for us. We have x plus 1, which is seen in red here. X plus 1 here, x plus 1 here, so x plus 1 for this part, and x plus 1 here. And then we have the lines y equals 2x minus 4 graph, which we have this intersection point at 5, 6. And then we have the line y equals negative 2x plus 4 graph, so we have this intersection point 1, 2. So I'm graphing 3 lines, and you can graph all 3 on the same xy coordinate plane if you want to. And I have 2 different intersection points because I have 2 different x values that will make the equation true. I have x equals 5 and x equals 1. To check this, I'm simply going to plug the number back in to make sure I don't have any extraneous solutions. So I'm going to say the absolute value of 5 plus 1 should be equal to the absolute value of 2 times 5 minus 4. When I do that, I get the absolute value of 6 equals the absolute value of 10 minus 4, which is also 6. The absolute value of 6 does in fact equal the absolute value of 6 because 6 equals 6, so that works. I'm going to try again with 1 to make sure it's not extraneous. So 1 plus 1, absolute value of 1 plus 1 should equal the absolute value of 2 times 1 minus 4. Well, what that says is the absolute value of 2, which is 2, should equal the absolute value of negative 2, which is also what? 2. So that also works. Does that make sense? That definitely requires a bit more work. If you have a graphing calculator, it's super easy, okay? Now again, if you have one or not, you will have to demonstrate the skill by hand, but this can make the homework go by faster, and it can help you verify your solutions. So what I'm going to do is actually plug in both of those absolute value equations into my calculator. Absolute value of x plus 1 and the absolute value of 2x minus 4. I'm going to go to y equals. Alright, sorry we had a bit of a snafu. Uh-oh, it just disappears. I don't know why it does that. Well, I was not anticipating that. It's alright. Let me exit out of this. With that, click run. There we go. Alright, so if you have your graphing calculator, what you want to do is you want to be able to enter the absolute value. So you wouldn't have to change anything at all. You would just enter both absolute value equations. Well, where do you find absolute value? Any of the yellow buttons that you want, you have to press second first. Any of the aqua green or whatever this color is, you have to press alpha first. So to access the absolute value, you want to press second and go to catalog. And that should be probably the first thing that you should see. You should see this abs thing. Press enter and then enter the equation x plus 1, or not the equation, the expression x plus 1. Do the same thing, go down to the second y equals, go down to second catalog, so press second, then press catalog, choose the ABS for absolute value, and enter 2x minus 1, and hit graph. What you'll notice is that it graphs both of those absolute values, right? And you see what? Two separate intersection points. These intersection points should match the points that we came up with. So, to remind you again, you're going to go to second, calculate, go to intersect, down to number 5. You can press number 5 if you want, which I'm going to do. It says first curve. So we're going to look at this intersection point right here. So that's fine. I'm going to press enter. Second curve. I'm going to press enter. It says guess, and it's going to tell me that that intersection is 1, 2, which we see is right here. Does that make sense? And then you're going to do the same thing to this point. The only difference is you're going to move up, okay? So you're going to go to second, calculate, wait a second, calculate. We'll go to intersect, number 5. And this time, we want to go closer to this point here. So I'm just going to scroll till I get closer to that point. I'm going to press enter. And then, same thing here on this curve. Second curve, I'm going to press enter. Press enter again where it says guess. And it gives me that intersection point at 5, 6, which is right here. So again, a useful tool, one that you will definitely need in Algebra 2 and beyond. Let's move on to this practice problem, which you had some time to practice earlier. You should have gotten the solution x equals -4 and x equals 0. If you got that, then you did it correct. Let me set up those equations again for you. So, based on our definition, 2x plus 2 is equal to x minus 2, and 2x plus 2 is equal to negative x minus 2. I have to distribute that negative to that expression on the other side of the equation, and I get 2x plus 2 equals negative x plus 2. I'm going to be graphing 3 lines. I'm going to graph the line y equals 2x plus 2. Y equals negative x plus 2. And then y equals x minus 2. And I should have 2 separate intersection points, and those x values are the solutions. You can check it, and you will see that they both work in that instance. Now, somebody earlier asked, do I have to put the negative on the right side here? The answer to that is no. You can put the negative on the other side as long as you remember that this equal sign allows us to use what's called our multiplication property of equality, which says if A equals B, if I multiply a times some constant c, I have to do the same to the other side. So if I want to get rid of this negative here, that's fine. I would have to multiply by -1 there and -1 there, which means I now have to distribute it to the first equation instead of the second. Do you have any questions? All right. We're going to take a look at this word problem. All right, so we're going to take a look at a word problem here that your book talks about. And actually, to find the solution by graphing, it is something that you would have to use your graphing calculator on. You could definitely attempt to graph it by hand, but it would be a nightmare. We're actually going to solve this not by graphing at all and still come up with the same answer. But I do want you to see the context of this problem and how to set it up. It says your family needs to rent a car for a week while on vacation. Company A charges $3.25 per mile plus a flat fee of $125. Company B charges $3 per mile plus a flat rate fee of $150 per week. After how many miles of travel are the total costs the same at both companies? So when you are looking for, or when you see in a word problem where it asks you, when are they the same? When are they equal? When are they equivalent? Any of those words that mean equal, then you're going to set up two equations that are equal to each other and solve. So what is the equation for company A? A equals what? $125 plus, let's put the 3.25 first. Yes. 3.25x plus 125. And then for company B, you're going to do the same thing, only it's 3x plus 150. You would use your graphing calculator graphing to find that intersection point in the way that I showed you, or you can simply set them equal to each other and solve. 3.25x plus 125 equals 3x plus 150. So we can subtract 3x from both sides using our subtraction property of equality. And I'm going to use a different color here. You end up with 0.25x plus 125 equals 150. We're going to keep going, and we're going to go ahead and subtract 125 from both sides. And we get 0.25x equals 25. We simply have to divide. Divide both sides by 0.25. Remember how I get rid of this decimal here in the denominator? So how do I make that 25 as opposed to a 0.25? What happens if I multiply the numerator and denominator by 10? How much does it move the decimal place over? Okay, so I have to multiply both by what? 100. So if I multiply the numerator and denominator by 100, I'm just simply changing the form at 2,500 over 25. And then I simply have to divide, and I get 100. X equals 100. So what does that mean? What does that 100 mean? After how many miles will the cost be the same? After 100 miles, the cost will be the same. Questions on that? All right. For those of you that are gone and you're watching this video, or for those of you that weren't gone and you want to know your table of contents, this is your updated table of contents. Item number 12 is the newest item on your table of contents. 5.5, page 265, 3 through 27 by 3. So what that means is 3, 6, 9, 12, 15, etc. I want to give you the odds so that you can check your graphs, and that will be it for your homework tonight. Please make sure your table of contents is updated. That is due the day of the test on the 15th of December.